The question says if the square parentheses or square brackets of x denotes the greatest integer less than or equal to x, is that operator applied on x equal to 0? We have two statements, 5x plus 1 equals 3 plus 2x. And the second statement says x is between 0 and 1. The information prior to the question gives us a definition for the operator. A definition using a description that we can graph over here. Take a look. We're talking about, first of all, that this symbol that depends somehow on x is an integer. Let's say an integer n, okay, capital N. So we need to realize that being the greatest integer less than x or equal to x, you can figure out that n must be to the left of x on a number line. It could be x, actually, but since it is less than x, it has to be to the left of x or be just x. These are the possibilities. But since the definition says that it is the greatest integer possible, so that means that there is no other integer closer to x from its left. In other words, the next integer after n, which would be n plus 1, right, couldn't be on the left side of x. This should be on the right side because there is no closer integer to x than n. N is the closer, but, coming from the left because it is supposed to be a number less than. So what we see here is something that we can describe using an inequality, actually. This would mean that x is a number between these two integers. But since we need to consider also this condition, the possibility that this integer n is equal to x, then we need to consider here this symbol. That is, x might be n. Okay. If we have translated the definition of this operator square brackets in this way, so that saying this is exactly the same as saying this. Well, if this is true, then let's reformulate the question. The question says, is the square brackets of x equal to 0? This is exactly the same as asking whether x is a number between 0 and 0 plus 1. In other words, is x greater than or equal to 0 and less than 1? That is a true question we need to respond to. So let's try with statement 1. The information it provides is a linear equation with a single variable, so we can easily isolate the variable. It turns out that 3x equals 2, so x equals 2/3. But 2/3 is actually a number between 0 and 1, so we have an affirmative answer to the question, and unique, by the way, so statement 1 sufficient. Statement 2 says that x is any number between 0 and 1, but if x is any number between 0 and 1, then the answer to the question is affirmative because this interval is included within this one. So we have sufficiency in statement 2, and the correct answer choice would be each statement alone is sufficient.